Hello everyone, this is a video lecture for Pre-Calculus section 5.4, more trig graphs, if you didn't have enough. So I'm going to just refresh us on sine x, looks kind of like this, cosine x, again these are not perfect, so something kind of like that probably, it's good enough. Now let's do the new ones. Tangent, looks kind of like this, actually. Dot, 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 dot. It has asymptotes. In fact, it keeps going. There's a whole lot of these on both sides. But we're going to focus only on this guy right now. So it has some asymptotes on either side. Cosecant is related to sine, if you remember. So what we actually do, what I'm going to do, is I'm going to draw a sine. Oops, that's a cosine. Sorry. Start over. Draw a sine. And then what I'm going to do is draw little U shapes that have asymptotes on the tops of the hills and the bottoms of the valleys. The asymptote is whenever it's at 0 right there. So I didn't draw it perfectly. And this is also another asymptote right there. And another one right there. And then, of course, there's more U's, on tops of the hills and bottoms of the valleys and stuff like that. So the actual graph of cosecant are these U shapes. Same thing with secant. I'm going to start with cosine, because it's related to cosine. Trying to do little dot things here. It's actually a little difficult. And so then I'll do little U shapes on the hills and valleys. Asymptotes are wherever it's touching the x-axis, just like that. And again, this will keep going, and there's some more right here, and all that stuff. Okay, cotangent, last one. This is the one that I have a very hard time drawing, so please forgive me on this. It does this. Oh man, I can never draw this very well. I don't know why. I think it's maybe because I'm right-handed or something. Okay. There we go. 0 is an asymptote, and it goes all the way out to pi. Now, compare this one to the tangent right here that I had drawn. This is actually negative pi over 2 to pi over 2. Okay? So it's a little different. Both of those have something in common, though, and I'm going to show you the differences and common similarities and all that stuff. Sine, cosine, cosecant, and secant, all of these guys are related in the fact that they have a period equal to 2 pi over b. On the other hand, tangent and cotangent have a period that's a little different formula, is equal to pi over b. Now b is, of course, what we've already seen before in the previous lectures and stuff like that. So it is kind of going to be different. Whenever they say tangent or cotangent, I have to change my formula for the period a little bit. And if you don't do that, then you'll, well, get it wrong. So watch out for that. It's a very small change, but very important. Let's start doing some of these. I honestly do not have a very lot of questions from this section. So let's just do what I got and go from there. 3 cotangent of 2 pi x. So first off, my period, because I have a cotangent or tangent, it's just pi over b. This is my b right there, that 2 pi. The pi's cancel, leaves a 1/2. So my period is 1/2. Basically, wherever I start to my finish, it should be a half. Notice that we have a cotangent. Cotangent does this guy right here. Oh man, I can just never draw this one. That's close enough. And where it ends, the asymptote where it ends this time, it ends at half. This is at 0. This period is a half. There you go. So what does this 3 do here? Well, I mean, not much, honestly. I don't know. Let me try to draw it like that's. If that's a 1, then a 3 would look something like this maybe. Okay? It just stretches it out vertically. It really does not change it significantly. If I were to be asked, well, compare this one, if this has an amplitude of 1 and this has an amplitude of 3, it would be a tough time for me to figure it out. I'm just saying. That's a tough little thing, but it looks something like that, okay? Let's do another one. 5, 4, 0, 31. Y is equal to 3 secant of 2x. Notice secant is kind of related to cosine. Therefore, my period is equal to 2 pi over b. 2 pi over 2. The 2's cancel, leaving a pi. Okay, so with that, I'm going to draw a cosine graph. Secant and cosine are inverses, so cosine graph. And notice that my amplitude is 3. I mean, basically what I'm doing then is I'm starting not at 1 here, but I'm starting at 3, go figure. But it doesn't really change the overall shape very much, so I don't want to say I ignore it, but, well, kind of. It's a negative 3 to 3. I just make that up. Well, this is my cosine. That's what I would draw, and again, it's going all the way here to pi. So there's what if I had it as cosine right here, I'm done. But because it's secant, basically I'm just going to do the u's. Oops. Do the u's on the tops of the hills and the bottom of the valleys, and of course asymptotes wherever it's touching the x-axis. And there you go. That's my graph. This stuff right here, this solid, that's my graph. I don't think WebAssign is going to give you my cosine graph. I don't think they're going to draw this thing in the middle. You'll just see a lot of U's all over the place. Well, what I do is I just draw on the screen a cosine graph and make sure it looks the same. I don't know. You can use a pencil, erase the screen writings later. It's kind of a joke. I don't recommend doing that to your monitor. But moving on, x. So 3 cotangent of x plus pi over 4. Now notice that, again, I got this plus sign right there. It should be a minus sign. If I were to rewrite this, let's say, I got 1x minus a negative pi over 4. Okay? So my period is 2 pi over b, 2 pi over 1. I'm sorry, whoa. Back up. See, I even messed it up. Look, I'm messing it up. That happens. My period is a cotangent tangent thing. It's pi over b, pi over 1, so just pi. Whew. Watch out. Amplitude is 3. And notice that my phase shift, I guess C, my phase shift is going to go to the left. A negative pi over 4. So I'm starting at pi over 4, negative pi over 4, and I'm going a distance of pi. What does that look like? Well, I guess I start right here at negative pi over 4, and I'm going to go a distance of pi. So this will end up here as being 3 pi over 4, if I do the math correctly. So I have an asymptote right here, asymptote right here. Let's say this is about the middle, about right here. That's about right. And so then I'm going to come in about the middle, and then I'm going to drop on down. There you go. Cotangent graph. Very difficult for me to draw. I don't know why. Just that one in particular. 5, 4, 0, 43. Y is equal to the tangent to x minus pi over 6. First off, notice that I have my b. My period, because it's a tangent, is pi over b, pi over 2 in this case. Well, that was it. I'm shifting to the right a positive pi over 6. So my original graph looks something kind of like this with some asymptotes. And so this is a pi distance, starting at negative pi over 2, all the way to pi over 2. Well, what I'm doing is I'm shifting it to the right a little bit, okay? And then my period is also changing. It was a pi distance, now it's a pi over 2 distance. It's basically shorter distance there. So let's try to graph it. Pi over 6 is where I'm shifting it. Again, I'm shifting it there, that way. So that my center now is right here at pi over 6. And then I'm basically just going to do my little tangent thing. And exactly where these asymptotes are, it's kind of hard to pinpoint. I know for sure that this distance here is only pi over 2, and so I guess you could say this is a pi over 4 distance on either side. I'm just cutting it in half. So you could say pi over 6 minus pi over 4, pi over 6 plus pi over 4, whatever you want to do. This should be good enough. Again, this is multiple choice stuff, just A, B, C, or D. Pick that one. You could also use a graphing calculator, but I'm not recommending it because we're not thinking that way for the exam purposes and stuff like that. So again, that's why I'm doing all of this by hand. Okay. So I got another cotangent. Notice that I'm going to have to rewrite this guy. 2 times x minus. And if I'm pulling a 2 out from both of these guys, remember we've done this before. I create a 2 over 2. This guy's going. So what I'm left with in the bottom is a pi over 4. Okay. So I'm going to shift. This is to the right this time. I have an amplitude thing. It doesn't really affect it too much. My period is pi over b, so pi over 2. Okay, remember that formula is pi over b, not 2 pi over b, because it's a cotangent or tangent. Okay, so I'm shifting it to the right by pi over 4, and then my period has changed. Let me show you what that should look like. This is 0. This is pi over 2. Oh, I'm sorry, pi over 4 is where I'm starting. And I'm supposed to go a pi over 2 distance. So this ends up being, well, 1 pi over 4, and this is, I guess, 2 pi over 4 makes a 3 pi over 4 in the end. Again, asymptotes here and here. It's a cotangent, so in the middle, we're going to kind of just do this. It's like a backwards cubic. That's good enough. Okay, this is the last question I have from this section, and I'll talk a little bit about my selection, my choice of questions here in a second, okay? So secant 2 pi x minus pi, and I need to simplify this thing. So first off, I could pull a 2 pi, actually I need to pull all of this out, because again, my formula is x minus something or other with a number right here. This is always a 1. It's always a 1 right there. So 2 pi needs to come out of both of those guys. The 1/6 can kind of stay. That's easy. 2 pi comes to the front. X minus, well, if I'm pulling a 2 pi out of both of these guys. I'm pulling a 2 pi here. The pi comes out. But remember, I mean, I guess you can always just do this to verify. This guy's coming out. The pi's are going to cancel, leaving you with a half. Just a plain old half. And so that's going to be a shift to the right. Again, inside opposites. There's a minus sign. Inside opposites. That's my b, so my period, remember that it's changing back to 2 pi over b here because we have a secant, cosecant, a cosine sine kind of thing. So 2 pi over 2 pi equals a 1, so that's my period of 1. I'm starting at 1/2 and I'm going a 1 distance. So I'm starting here at 1/2 and I'm traveling 1 full distance. Notice 1/2 minus 1 is going to be at 3/2. This, again, remember, this is kind of like a cosine, so I'm going to think like a cosine and draw a cosine, and then from there I'll fill in the whatever. My amplitude is just 1/6. Again, that's all relative, so it's just, that's good enough. We start at pi, come down low, probably a bit too fast there. And back up. Well, it's close enough. You get the idea. And so then I got my U-shapes. Just like that. Asymptotes wherever it's crossing the x-axis. Okay, there you go. And there's my graph. That's all. So you might think, well, wow, you didn't do all these graphs, and there's a ton of tough ones and stuff like that. So one, I'm going to say, is that I'm just following the notes that I had from last semester. Well, I guess it was last fall, when I taught this in class, in person. Not in person, it would be live streamed. But, I mean, same thing with this. I'm teaching it just as if I were to teach it in class. I'm just not pausing for questions. Like, hey, anybody got questions? I would normally do that in class, but I don't have anybody to, do that. So, okay. The other thing is that I can't do every single question on the homework, not just because of time's sake, but because you need to train yourself using these homework questions as well. So don't just run to a calculator. Don't just guess until you get it right. These are designed for you to learn so that later on you can actually know what to do when the situation arises, especially when it comes time to quizzes and very importantly for exams. Okay, that was a short section, but we're done. Thank you very much. Have a great day.